Assalamualaikum and hi everyone. Welcome back to chapter 5 vectors. In this video, we will proceed with 5.2 scalar product part B. Use the properties of scalar product. The properties of scalar product: if A and B are two non-zero vectors and M is a scalar, then A dot A will be equal to magnitude A squared. Number 2, commutative, which is A dot B will be the same as B dot A. Number 3, associative, which is the position of M could be anywhere, where we have it MA dot B will be equal with M multiplied with A dot B will be the same as well with A dot MB. Number 4, distributive, which is we can expand the A into the bracket, which is we're going to have A dot B plus A dot C. And then for the number 5, we have it 0 scalar, which is 0 dot with a vector, will be equal to 0. Number 6, parallel, which is if A parallel to B, we will have it either same direction or opposite direction. And then the most important properties, which is number 7, if A perpendicular to B, we're going to have A dot B equal with 0. So usually for these properties, we will use in order to show that two vectors are perpendicular to each other, or you will need to use it to find an unknown by given information which is A perpendicular to the B. So let's try a few examples. Example 5a. So simplify two parts, which is part A, we have B minus A dot 2A plus B. So first thing, you have to expand these two brackets one by one. So we're gonna have B dot 2A plus B dot B minus A dot 2A minus A dot B. So by the properties, number 1, we can have it A dot A equal with magnitude A square will be the same as B dot B will be magnitude of B squared. And then for the commutative properties, where we have it A dot B will be equal to B dot A. So you can simplify, which is we're going to have 2 A dot B plus magnitude of B square minus 2 magnitude A square minus A dot B. So now, as you can see, we have the same item here. So we can combine. We're going to have a single A dot B plus magnitude B square minus 2 magnitude A square. So we have done part A. Now, we proceed with part B. The same pattern, which is we have to expand one by one. So we're gonna have the first part, which is C dot A minus C dot B plus 2B dot A plus 2B dot C. So C dot A will be remain as like that. And then we can change the C dot B with the B dot C. As you can see, it's commutative properties. So we can change it to be minus B dot C. So since we have the same item here and here, so we can combine. So literally we end up the final answer will be plus B dot C with the C dot A plus 2B dot A. Easy peasy, right? Okay, so now let's upgrade a little bit more for the next example. Example 5b. Given that two vectors, vector A and vector B, we have to find the value for t by given A is perpendicular to B. So remember, by the properties of number 7, when we know that A is perpendicular to B, it means we can have it A dot B equal with 0. So you can have it the dot product of A and B, and then we equate with 0. So we're going to have A dot B equal with 0. So we have it as a column matrix, 3, T, negative 2 for the A. For the B, where we have it 1 minus T, negative 3, and then 4. So solve this one. We're going to have 3 minus 3T minus 3T minus 8. So by simplifying the T first, we're going to have negative 6T. 3 minus 8 will be negative 5 equal to 0. So we have it 6T equal to negative 5, and then T will be equal to negative 5 over 6. Okay, example 5C. Given two vectors U and W, find the dot product of U and W. So U dot W, by the column matrix form, we have it 8, negative 2, 5, dot with negative 4, 1, beta. So we're going to have negative 32 minus 2 plus 5 beta. So we are going to have it 5 beta minus 34. Okay. And then it said that hence, it's mean you have to use the previous part, which is your scalar product, in order to determine the beta value by given U is parallel to W. So by the properties of scalar product number 6, U parallel to W will be represented by U dot W equal to magnitude U times magnitude W. So the dot product of U and W, we already found it. Now you have to find the magnitude of U and W before we proceed to the next part. So magnitude of U, where we have it 8 square, negative 2 square plus 5 square inside the square root. So we're going to have the square root of 93. And then magnitude W, where we have it negative 4 square plus 1 square plus beta square. So we leave it in terms of beta square, which is 17 plus beta square. So now we can substitute these three values into this formula. So we're going to have 5 beta minus 34 on the left hand side. On the right hand side, where we have it square root 93 times square root 17 plus beta square. Okay, so to cancel out the square root, we have to square both sides. So the left hand side, where we have it 25 beta square minus 340 beta plus 1156. While on the right hand side, we're going to have 93 times 17 plus beta square, which give the value which is 1581 plus 93 beta square. Okay, so we collect everything to one side to make it the beta square as a positive value. So we're going to have 68 beta square plus 340 beta plus 425 equal to 0. So before you use calculator, you need to simplify this equation first by divide with the 17. So we're going to have 4 beta square plus 20 beta plus 25. So we can have it factorized, which is 2 beta plus 5 square equal with 0. So directly we have beta equal to negative 5 over 2. So that's it for now. I will see you again in the next video. Take care and bye bye.